question 5. So for part A, F equals ma or A equals F over m. We're told that the force in vector form is 3i minus 2j divided by the mass, which is 0.5. Dividing by a half is actually the same as doubling it, so 6i minus 4j is the vector of the acceleration. Now we've been asked to work out the magnitude, the size, so just using Pythagoras, so the size squared equals 6 squared plus 4 squared, so the acceleration, the magnitude of the acceleration is root 52 or 2 root 13 as required. Part B, we're just using from Suvat v equals u plus at and simply substituting in the vector for I, the vector for A that we know from part A, and time is 2, giving us v, the final speed in vector form, 13i minus 5j. Now for part C, we've got a new particle q moving at this speed, this velocity. Find the distance moved in 2 seconds. Well, let's just work out the magnitude of the velocity to start off with, again using Pythagoras. So that is root 5. So that's in unit form. So for 1 second rather. So in 2 seconds, it's going to be the distance travelled is going to be 2 lots of root 5 meters per second, which is 4.47 meters. Now for part D, we really want to show that both P and Q, the final vectors, are multiples of the same vector. Now I think it's best just to leave Q alone because that's just a sort of a single vector. So looking at P, we want to go and work out the vector for P after 3.5 seconds and show that it's a multiple of 2i minus j. So P after 3.5 seconds, using v equals u plus at, the initial speed was I plus 3j from here. We know that the acceleration of P is 6i minus 4j from here. So after 3.5 seconds, we've got 3.5 lots of pi, 6i minus 4j, which is 21i minus 14j. That added together with the initial vector gives us 22i minus 11j. Factorising, taking the 11 out, we get 11 lots of 2i minus j, which is just the job. We've shown that it's a multiple of velocity of the velocity of q, and therefore they're moving in the same direction.